We're super excited to be here at Security Field Day. As you mentioned, we had a chance to participate in a few network and cloud field days in the past. Always had a blast, and we're sure it's going to be the same today. The main topic of our discussion is going to be network detection and response and how that can be leveraged as a part of your security strategy for your ecosystem. We're going to cover first just a brief overview of Kemp for those who maybe aren't as familiar. We'll then look into some of the principles and approaches that we found from our own experience in working with customers are useful for building a network threat detection mindset and approach for your ecosystem. That's going to take about 20 to 30 minutes. The last section, we're then going to hand over to Pavel Minarik, our CTO, and he's going to dive deeper into the product architecture and also show some real-world scenarios of how our product set can be leveraged for mitigating some of the common threats that we're seeing today. On that note, Pavel, why don't you introduce yourself?
Hi everybody. This is Pavel Minarik from Flowmon Networks/Kemp Technologies now. I work in the area of network performance monitoring and diagnostics and network detection and response for more than 14 years now. And I was always on the product side, working on the product roadmap, working as a developer originally at the beginning, and architecting from scratch our network detection and response system.
As I said, super excited to be here at Security Field Day. Quick overview on Kemp for maybe those who are a bit less familiar. We established ourselves in the early 2000s, and the kind of core value prop of what we deliver is centered on application load balancing, availability, and all the things that come along with it. If you rewind yourself back in the IT landscape back to that period of time, there was really a big underserved part of the market. Right. If you look back in the early 2000s, when it came to things like load balancing, application proxying, and the like, you had on the one hand of the market high-end hardware-centric solutions that were focused and centered on custom FPGA and silicon development. You did have some software and open source solutions, but they just weren't really that mature. So you had this big gap that existed in the middle. If I was a customer that had mature requirements from a capabilities perspective, but perhaps limitations from a budget point of view, limitations even from a skill set point of view, if I didn't have high-end expertise, I didn't really have a solution that was available for me. And so that was the part of the market that we sought to focus on by taking a software-first approach. Our model was effectively take the software magic that we had built, figure out how to take advantage of x86 COTS platform, selectively use ASICs, and build a solution that was for that part of the ecosystem. So of course, as you fast forward through time, things like virtualization and cloud came about, and we were well positioned to take advantage of those trends. Now, since then, we've grown to be a global company, over 300 employees, and varied ecosystem integrations across the technology landscape, along with customers across all sorts of domain. Prior to last year, I spent most of our time out of our New York office, as well as our Limerick, Ireland office. Looking forward to getting back to those places. Now, something that we've seen happen over time is that the expectations and requirements of what a load balancer or an application delivery controller provides has shifted. There's been an increase in requirements around security capabilities, right, as part of the buying criteria. If you think about a load balancer at its basics, it is somewhat of a basic firewall, right? Because I'm terminating traffic, I'm doing some level of deep packet inspection in terms of making decisions. Given its position, it often is leveraged almost as a last line of defense for your application security. And it's a place where I consolidate other security functions. I mean, I'm storing certificate information as an example. I will add in web application firewall, authentication, integration with your identity access management system, and the like. And so those are core things that we have within our foundational load balancer product set. But as was mentioned in the introduction, we've expanded our capabilities further recently with the acquisition of Flowmon Networks. That's the Flowmon product line that we're going to spend most of our time on today. This additional set of products helps us with additional network visibility, as well as threat detection, which is really the cornerstone of today's discussion. Now, this is a good time to segue into what the product portfolio actually looks like. You could think of it almost kind of sliced into two, right? On the one hand, within the product portfolio, we have the parts that deal in active network participation, right? The things that I mentioned, the load balancer, web application firewall, DNS-based traffic distribution for getting traffic across multiple sites, multiple clouds, and the like. The Flowmon product line within the portfolio is then centered on observability, helping you to have insights about what's going on in the ecosystem. At the heart of that is our NPMD functionality, network performance monitoring and diagnostics, right? By leveraging access to flow data in the network combined with just-in-time access to full packet capture insights, I'm able to get a clear view on what's the state of your network from a performance perspective, from a troubleshooting perspective, from a WAN connectivity perspective, and the like. Again, though, I'm able to leverage that privileged information for doing other interesting things. I can use that vantage point to start to detect when there's anomalous behavior that's happening within your ecosystem. I'm looking at everything anyway. I might as well tell you about it if I see something that could be leading to a security threat. Now, the last part of that portfolio is then the application performance monitoring. And I would say this is network-centric APM. We're not looking at code execution paths within the application ecosystem, but again, using the network insight data that I'm capturing, I'm able to tell you about things that you could do to improve your application experience. So as an example, if I see that HTTP request to a front-end website, every time you request certain images, well, that's taking a really long time to load. Or if I'm looking back at my SQL queries and I can see that certain transactions are taking a really, really long time, well, I can give you insights that if you fix those couple things, the overall application ecosystem will perform better and your users are going to get a better experience. So today, as noted, we're going to focus on the network detection and response part of the product portfolio, but I'm sure in future field days, we'll get a chance to dive into the other aspects as well. Just summarizing, right, the core value prop that this product portfolio brings together. As a load balancer, we've got deep layer 7 application insights and the ability to do smart things within your network from just a traditional load balancing perspective, but also from a security point of view. The addition of the Flowmon product line, well, that now gives us deeper visibility from a networking perspective. When you combine both of those product portfolios, when you deploy those things together, you start to get some interesting use cases and value propositions. And we are going to be developing a rich roadmap of deeper integrations between those two product sets. The first iteration of that is actually going to be coming out next quarter, and we'll have some interesting announcements on that coming up. Now, the last angle of this is the security perspective. At an application layer, I need to apply security at the HTTP stack, and I also need to get insights on what's going on in my network from a security and threat perspective as well. This is what our product portfolio attempts and successfully does help customers to do. So with this backdrop in mind, bit of background on Kemp, we'll now progress to discuss some of the principles and approaches that we found successful in helping customers to address threat detection and response requirements. I'm Jason Dover, VP of Product Strategy at Kemp Technologies. We're super excited to be at Security Field Day, chatting about the topic of network detection and response. In this section, we'll be discussing principles and approaches for network threat detection. This is going to lay the groundwork for looking deeper at the Kemp Flowmon NDR product line and how these approaches is leveraged within our product stack. So quick question for you. Have you ever thought about the difference between a puzzle, and a mystery. This is something that's been covered in a variety of more recent editorial works after certain scandals that have made the news. Malcolm Gladwell, fairly famous writer, today talked about this in the New Yorker. Here's the interesting thing. It's described that a puzzle is something that has a simple factual answer that's solved simply by getting more information. Right? If you increase the collection of intelligence, you get closer to the answer. Imagine the location of a single bad guy. All you really have to do is find an informant that either is willing or can be coerced or bribed into telling you about where they last saw the bad guy, right? Think about this from a cyber perspective. If you wanted to find out, you could fairly easy see who the first genius was that opened the I love you email within your infrastructure and launched the I love you bug into your email environment, helping you to have a really good day, right? All you gotta do is go look at the logs, right? However, mysteries are different. Mysteries, they have contingencies. They're solved not by just getting more information. You've got to get the right information and you've got to analyze it. Think of your favorite Agatha Christie or Sherlock Holmes story, right? The fact that you know that the driver, the butler, the ex-wife, and 2 stepchildren that were excluded from the will were all at the house when the victim lost his life, that doesn't make it any easier for you to figure out the crime, right? In fact, it does the opposite. It makes it more difficult to understand it sometimes, the more information you have. It's really about the analysis that you're doing and getting access to the right information. Think for a moment back not so distant past to the Stuxnet virus, right? And of course, there's all sorts of still arguments of what state actor actually developed it, but that malware had pretty devastating effects. It attacked SCADA systems, attacked Windows. But think about it, a lot of information actually was available, right? Here, there was knowledge of it for some 5 years before it started showing up in places it shouldn't. It was a 0-day attack written in C and C++, which weren't very common for that type of malware. It was digitally signed with private keys from known and trusted entities, and it had the ability to sit in plain sight dormant until the correct operating environment was introduced. And so just getting the information really wasn't enough. You had to be able to interpret it properly. You had to have access to the right information as well. And that's the point. The complexities of modern IT demand not just information, but the right information. So more dashboards aren't really going to do it for you. You've got to have the right techniques and the right framework in place. This is why it's our belief that network detection and response is a really key element to helping you to solve this challenge, these problems. And just think some things about what we've been seeing recently, right? Increase of infrastructure attacks, increase of ransomware. Why is this? Well, you've got legacy infrastructure that's sitting right alongside IoT infrastructure, which doesn't necessarily have the best track record. So you've got this petri dish that's rich for getting attacked, basically. I mean, I mentioned to you in my intro about the fact that that I used to work in the finance industry. And you'd be surprised. I mean, well, I know some of you wouldn't from your backgrounds too, but the largest financial industries, companies, the legacy infrastructure that's still there, held together by tape and strings, it's very surprising. And so now you're introducing insecure IoT infrastructure on top of that. This is why we're seeing the increase in infrastructure attacks. You know, if you check the right places of the internet or the wrong places, depending on your mindset, you can literally find service providers that will provide you with ransomware as a service platforms. And so the numbers and figures that we've seen over the last couple of years supports this. Identity access continues to add complexity as well. IT still has the challenge of balancing security versus usability. If I make people change their password every other day and require 15 special characters, well, that's a problem, but I can't let people have their password be password either. But this is a key conduit for attacks. Again, without having to rewind back too far, think of the SolarWinds attack of just a few months ago with the teardrop exploit. Where did that start from? Stolen credentials that was able to be used to get lateral movement and launch remote access exploits. And then once I'm in there, they used file replacement techniques and a number of other methods that were, of course, disastrous. The last challenge or complexity is then zero-day and polymorphic attacks. Of course, Stuxnet, which we mentioned just as an example, that's both zero-day and polymorphic. But again, we don't have to go back that far in history. Just earlier this month, the Hafnium attributed zero-day threat attacks against Microsoft, where an attacker could get access to the Exchange system, exchange mailboxes, and then launch additional pieces of malware. And the point here, right, is that the frequency of the occurrence, of these things is the norm now. We just covered a couple of examples that we hear about, but when you look at Verizon and other people's reports, we can see that there's a lot that we don't hear about that has a very significant negative impact on the industry as a whole. So what do we do here? How do we solve it? Well, we put in different pieces of infrastructure to try to help us to mitigate it, right? You've got your edge security or perimeter security, your firewalls, IDS, et cetera. And this is a start, but it's not the whole picture because I'm really only able to address traffic that vertically transits the boundaries of my network ecosystem. So I go to the other end of the spectrum, right? I deploy endpoint security to make sure I can protect users from their self, help prevent the endpoints themselves from being compromised. I'd add in there also application layer security. So things like web application firewall, looking at what's going on at the higher portions of the network, making sure I'm integrated with my IAM appropriately and so forth. But again, that's limited because that gives me narrow and deep visibility, again, on only one slice. The question then comes up of who's watching the network, right? If you think about either end of these things, there are ways and there are methods for threat actors to abstract what they're doing, to hide themselves, to use file replacement techniques, to change logs and wipe my footprints away. There's even, in one of the examples we're going to see later, the fact that it's possible to abstract malicious payloads in what looks like normal traffic flows. So having a deep understanding of what's going on in the network is critical. You normally are going to have to leverage network communications to successfully carry out your attack. And this is why security and visibility from a network point of view is oftentimes advantaged when it comes to the later stages of the attack. So let's say someone's got in, they've even compromised a device or a set of devices. In order to carry out the exfiltration, you can't hide that, right? And so in order to capture that, you need the right tools. And I'm sure many have seen this before, the SOC visibility triad or security visibility triad, as it's sometimes referred to. The point is that each of these addresses a different part of the anatomy of an attack, which we're going to look deeper into. The point of having all three covered is that you want to increase the probability of catching attacks and catching them earlier. Let's just briefly spend a couple minutes on each of them. Like we referenced already, compromised credentials are a big part of the exploit world, right? There's some statistics that say over 80% of successful hacks are actually related to compromised credentials. So having a deep understanding of what normal behavior looks like versus what abnormal behavior looks like is really important, right? Someone tries to log in 200 times in less than a second. It's probably not really a user. You should do something about it. Maybe cut that device off from the network, right? Combined with that is that, well, if you've got a large user environment, I need some way to collect all those logs, aggregate them, and parse them. And dealing with email alerts, manually going through logs, it just doesn't work with the scale of networks that we're dealing with. And so that's why both user behavior analysis as well as a way to aggregate the logs and insight are really key. The second part is EDR, endpoint detection and response. Once an asset or set of assets are compromised, this prevents a huge problem because from that point, I'm one step closer to now getting privileged access, which can be a real disaster. You're on the back foot at that point. So having real-time endpoint protection and response is another key pillar. And the third piece, And where Kemp comes in with the Flowmon product line is network detection and response. Now, historically, this was referred to as NTA, or network traffic analysis. NDR is probably a bit of a newer acronym that's been thrown into the industry. But this is really about identifying intrusions across the network, giving you a way to triage them and also narrow down to what really matters, right? So that you can filter out some of the noise, and incident responders and SOC operators can get to the stuff that really, really matters, effectively helping you to get ahead of things getting to their actual impact state. You may not be able to catch the exploit right at the beginning, but you want to catch the breadcrumbs before the full impact of the exploit comes up. Oftentimes it's, we see in Hollywood that the bad guy, the threat actor, hacking into the mainframe, and the good guy sees them and they're going back and forth and setting holes for each other. We know as security practitioners, that's not how it works. It's many small wins that ultimately lead up to the successful attack. NDR is about finding and detecting those, helping you to understand what's anomalous so that you can then stop it and prepare for the next time that it happens. And so if you put these three components in place together, you've got a better chance, not 100% chance, but a better chance at catching those potential compromises early. The second piece is having the right framework. If you just have the tooling in place, but you don't actually have the right framework in place, you could still somewhat be going in circles. And what we've found, and what we've found from our customers, is that the MITRE organization provides a really useful framework for thinking about threat detection, response, and really understanding the anatomy of an attack. For those not familiar with MITRE, it's a government-funded research organization that was spun out of MIT. They're funded by NIST and have connections with all sorts of three-letter acronym government agencies. The point of the framework is that it provides a blueprint of how threat actors will use tactics, techniques, and procedures to carry out an attack. It was originally developed to help provide a common language, common vocabulary, and way of looking at things for blue teams, red teams, and vendors, because now you're able to pool resources and efforts to get ahead of potential threat actors. It also provides a useful way for red teams to play offense, right? It's not just about knowing the anatomy of an attack so that you can prevent it from happening, but you can also pretend to be the attacker, right, in a preparatory way, so that you can set up a more robust infrastructure for dealing with threat actors and potential attacks. Now, what you see in the slide is the MITRE attack framework somewhat overlaid on the Lockheed Martin cyber kill chain along the horizontal, which many may be a bit more familiar with. The point of the attack framework was to go a bit deeper, though, right? The Lockheed framework provides a basic overview of what the anatomy of an attack and the methods look like. The attack framework goes several layers deeper and focuses a bit more on the exploit lifecycle. If you check out the website, if you haven't already, there's actually over 250 techniques and sub-techniques. And the point is just to get a really deep understanding of what are the types of things that happen at the different phases of an attack. The difference of this versus just relying on IOCs or indicators of compromise is that I would say those are somewhat rearview mirror looking, right? If you think about common IOCs that you get from threat intelligence, such as AV signatures, file names, hashes, IPs, it's about what's happened in the past. A framework like this is really about helping you to prepare what's for the future. There was a recent update as well. As you see, it was previously split into two. What is an attacker doing before they launch, and what are they doing after? The pre-attack framework actually was retired, and now it's all been kind of brought into one. So you've got one view to see what the anatomy of an attack looks like from the prep stage all the way through to the impact stage. And if you haven't yet, highly recommend you check out the MITRE attack website, tons of good resources and research. And so what we find is that even as we build our security products, looking at it through the lens of this framework is a really useful way to help our customers protect themselves. Well, the next step would be having the right intelligence, right? And you can think of threat intelligence, we're all familiar with threat intelligence platforms, the threat intelligence feeds. It really is about information that's been acquired from previous breaches and investigation. So I did mention it is rearview mirror looking, but that doesn't mean it's not useful, right? If I understand that attacker A typically leverages these IP address, these websites, these servers, these commands, this types of infrastructure, well, it does give me a bit of prediction, because if I see things that looks like that threat actor or that adversary again, I can understand what's likely to happen next. And that's really the point of threat intelligence. And of course, you can get feeds from FireEye, CrowdStrike, and a variety of other sources. Those feeds are used to enrich the investigation of a SOC analyst or of a threat responder. Now, I hope what's becoming clear here is that there is no one magic single bullet. And that's really what we always try to help our customers understand. Sometimes customers say, what's the one tool or set of products that I need that's going to secure my entire environment? The point is that that doesn't exist, right? It's putting these different methods, these different techniques, and these different tools together. That's the key. Now, the last part before we get into the product overview is that of the methods, right? So we've got the tools, I've got the intelligence, I've got the framework that I'm going to operate in. I need the actions of how I'm going to do it. And so a question that often comes up when we engage with customers and they're thinking about bringing some sort of network security monitoring insight into their environment, the question that arises is, do I go with a full packet approach or do I go with flow data? If you rewind back in history, monitoring your network for security from a flow perspective may have been seen as somewhat of a second-class citizen. And it's understandable because you're going to get the absolute highest level of fidelity by doing full packet capture. Right? With full packet capture, I'm getting a mirror image of everything that's going on in the network. A flow approach effectively is giving you a summary of what your connections have been up to. Right? Now, at its simplest, what is flow data? Well, flow is a 5-tuple data point that includes information about network communications, your source IP, dest IP, source port, dest port, protocol. And of course, that can be enriched with a bunch of additional information. So the question is, the difference that exists between the approaches, is it meaningful, right? Again, historically, this was the case, but with vendors like Kemp, we've introduced a bunch of intelligence into our method that helps to supplement the gap that you may have traditionally seen between full packet capture and flow. We do this by having intelligent probes that adds additional layer 7 metadata. And we also have what I would call just-in-time full packet capture. And so if we're monitoring the network, we're looking at flows. If an event happens, starts to happen, or we believe it's about to happen, we have the ability to do an on-demand full packet capture to further enrich the insight that we have about what's going on in the ecosystem. The other question, though, then just becomes practicality, right? When we had 1 meg networks, doing full packet capture and everything was feasible from a cost perspective, scale perspective, and so forth. With 10 gig, multi-gig, multi-terabyte ecosystems, that's just not always very practical. From a sampling point of view, flow is just going to scale better for your environment. Right? You can sample somewhere between 1 out of 64 to 1 out of 100 packets for gigabit scale bandwidth ecosystem. For multi-gig to multi-terabyte, you can do around 1 out of 1,000 to 1 out of 10,000, as opposed to mirroring everything that's going on. And you can kind of see how it progresses. You could very, very quickly, with a high bandwidth network, get to the point where you're just running out of scale. You're running out of capacity. And so our basic recommendation is, well, leverage a solution like Kemp Flowmon, where we rely on flow data primarily, but we are able to get access to full packet information when and as you need it. And in the demo we're about to go in, you'll see the depth of insight that you can get by leveraging this method. A couple of other things that just come up there. You also just have simplicity, right? There's no cabling of mirror ports. You don't have to worry about mirror port overloading, and the technical expertise to analyze the data which really is the important part anyway, is normally a bit lower when you're dealing with flow-based reporting as opposed to full packet capture. So plenty of benefits, as you probably guessed. Our method relies primarily on flow, but we also are able to use full packet capture for supplementing the insights that we see.
Jason, can I ask a question?
Sure.
You mentioned layer 7 metadata. So is this particularly good at detecting certain types of attacks and more at the higher layer and less at the lower layers? How does that sort of come together?
Pavel, maybe you want to take that question and give a bit more depth, and this will be a good prep for the couple demos that you're about to show.
So the primary mechanism is, as Jason mentioned, flow data. So that's the baseline. That's what the detection methods are using for machine learning, for adaptive baselining, heuristics, all these algorithms I'm going to talk about. But in application layer data, there are quite interesting information, right? Like DNS. So if the device is translating over a DNS, a domain that is known for being malicious, I can report that right away if I have the threat intelligence data. So that's the ability to leverage layer 7 information in the threat detection. Or there are things like JA3 fingerprints. So when the devices are establishing TLS session, they exchange certain information like what is the cipher suites that are available, what versions of TLS can be supported. And from that, you generate a specific fingerprint of the device, and there are known fingerprints for malicious traffic. Or you can use simple use cases such as which of my servers are actually still speaking TLS 1.0, which should be already deprecated, or TLS 1.1. So this is the additional insight that layer 7 metadata that are included in the flow records will actually give you. So you don't need to have the full packet trace all the time to have this information available.
I got one question too, if I may. Jason, you mentioned that you don't have to worry about mirror ports and overloading them and all of that. But flow data also needs to be picked up somewhere. And that's also something we need to carefully find a good spot or add some additional resources to grab them. So how are you doing that? I guess you're doing that in the presentation coming up?
Yeah, we will, and I'm sure Pavel will add to it, but nothing's for free, right? If I'm going to ship packets or ship even flow data information across the network, I do have to account for it, that my environment can handle it. The point here is just that it scales better and takes less capacity and less storage than what you would have to otherwise deal with full packet capture. For us, we can take flow data directly off of switches and infrastructure that supports exporting flow information. And we do also have probes that can get deployed. Some of the more advanced, fancy, smart stuff that I mentioned as well, you get that when you leverage our probes for capturing flow information off the network infrastructure.
Yeah, but as soon as you use probes, you need some way of getting the packets again. So that's a mirror port all over again, or you're using a tab, but then you only have one link. So you're getting back to the same problem. So in a way, the mirror port is always going to be some issue you're going to have.
You are absolutely correct, Jasper. The mirror port, when you want to use the probe, the mirror port is always there, either a local or ER span or through a packet broker. So it's always there. But the power of the solution is in the hybrid approach. You don't need to mirror port like all the data. You can actually do a hybrid deployment where, for example, from the branch offices, you will get the network telemetry from the Cisco routers that are deployed there. From the corporate data center, you get a probe, and then you have your AWS deployment where you get VPC flow logs. So that's the power of the hybrid approach that we have in Flowmon, and we can combine these different types of data, normalize them, store them, and process them with the data processing pipeline, visualization, reporting, anomaly detection. So that's the way how we approach the problem.
Okay, thank you.
Okay, Pavel, you got my attention when you mentioned you can grab more than what is officially in the NetFlow or IPFix standard. How many protocols can you decode with your solution from a metric standpoint? So do you have a rough number how much other protocols you can detect and grab metrics from them?
We have support for something like 20, 30 most common enterprise protocols. So it's DNS, DHCP, Samba, and things like that. So these are very common in all the environments. We also have support for some OT environment protocols. So, for example, IEC 104 or DLMS. So this kind of SCADA related protocols. And we leverage standard IPFix. So actually, our data is according to industry standard. We define enterprise extensions, and we create a standard IPFix packet. We provide the templates, so any third-party IPFix collector can actually understand and process our data as well. And this also enables us to understand other IPFix data. So if you take Cisco routers with the NetFlow version 10, which is basically IPFix, we can understand HTTP information from Cisco, normalize it to our HTTP information, and work with it in a standardized way. So that's the power of using different data sources and combining them in a single storage and single database.
Yeah, makes sense. I would say from a cybersecurity perspective, the interesting stuff is happening in the application layers. Yeah. So there, if you have additional headers, I'm just mentioning HTTP headers or other headers, there is often very useful information. Yeah.
Yeah, and that's exactly what you got. And when the system has a suspicion for some, let's say, critical anomaly that's completely configurable, it can capture you full packet stream, so you have your forensics data as well.
Quick summary here, which I think we all kind of got to. Don't leave the network out the calculus for your security strategy. NDR ought to be a part of the framework as you're looking at securing your own environment and helping your customers do the same.
Hi, this is Pavel Minarik, CTO at Kemp Technologies, speaking at Security Field Day. And I'm going to do a demo of a user account compromise use case. So first, let me introduce the use case, what we are going to see. This is based on an incident that we have detected in one of our customers' environment. So it's completely real case, including the PCAP that I'm going to use. In that specific situation, there was a device under the attacker's control. So the attacker was able to access the credentials of the user, and the attacker was actually trying to leverage those credentials to get access to other systems available in that specific environment. So what you are going to see in the demo is behavior-based detection, followed by signature-based detection, followed by full packet capture of that specific activity and built-in packet analysis. So let me jump directly into it. So now we are looking at the anomaly detection system, and we have seen a single event being detected and reported. This event is classified as a dictionary attack because obviously not all the credentials actually work for all the services and systems in the environment. So the attacker was trying to leverage the user credentials to get access to resources on a Samba server in the customer environment. So this attack has been detected and classified as Samba dictionary attack composed of some attempts with specific characteristics. So this is the algorithm modeling the entropy between the entities in the network. And from this, let's say, top-level view, I can drill down to all the details that I have about the event. So here you can learn some more details about what exactly was detected. Here is the mapping to attack framework. So this specific attack was classified as a credential attack or credential access using brute force password guessing technique. We can see timestamps of the detection. We can see the IP address, MAC address of the device that is reported as a source of the event. We can see event target, and we do have more details available upon request. So when I say event evidence, I want to see the network telemetry that actually triggered the detection. So now we are running a live query to the data stored in the collector, and we will bring up all the flows, all the network telemetry that is related to this detection. So we are able to analyze it in detail. We can filter the flows. And this is, I would say, like first level of forensic analysis, what was happening in the network.
Just one question regarding this, Pavel. How long can you store that? Is this just a matter of available disk space, or how long can you store these metrics?
That's actually another speciality of Flowmon. We can store this for weeks, months. It just depends on the disk capacity. So usually our customers have systems designed to store the raw flow data without any aggregation for months. This gives you also the opportunity to go back in time and analyze specific behavior in your network, even 1 month back, or analyze your network against an indicator of compromise that was previously not known and now appears, so you can check backwards your network traffic if that indicator of compromise has been detected there or has been reported there or not. So that's,
I guess a lot of your customers were appreciating that when they are looking back at the SolarWinds hack that was ongoing in February last year, yeah?
Yeah, and also for that Hafnium, I was consulting for a customer who needs to go back 4 months for the legal purposes, because the entities that are under the regulations, they were asked to provide the details for last 4 months about the potential activity of their network with known indicators of compromise related to Hafnium attack. So without Flowmon, it's close to impossible to do that job. Okay, let me move on to intrusion detection signatures. This is, I would say, expected. So there is a Surikata rule for this specific activity related to Samba traffic. So it's presented as additional context, not really the source of the event or the reason for the detection, but additional context to understand what might be happening there. And last part of the puzzle is the full packet trace that is available for that specific event. But you can also do more detailed analysis in the Flowmon system. So as I was talking about these modules, so now I will open the module called Packet Investigator that is actually able to capture the full packet data, and it's also able to run you a specific analysis of the full packet data out of the box. And with the built-in knowledge of the protocols, it will provide you the result of the analysis in a human readable form. So you don't need to open Wireshark, you don't need to have that specific knowledge. So this is my capture, and I will I will start the analysis and I will just analyze the Samba protocol because that's what we actually captured. So now I'm running the analysis in the background, this is indicating analyzing. So I should have a result of the analysis pretty soon. Let's wait for it. Yeah, here we go. So it indicates there is some problem. And when I open analysis, I can literally read what is in the traffic. So there is a Samba request, negotiation of Samba protocol version 2 that was successful. And then obviously client needs to authenticate against the server. And we end up with session setup error where you can read why didn't work, and you can get some tips like what you should check, what you should look for on the Samba server. This is a specific recommendation for that application protocol for that specific issue that was detected. And this is a knowledge built in out of the box in the system to provide the ability to analyze full packet data and just get the results.
So Pavel, another question regarding this. I think one of the hardest thing here is the data is coming in live. You need to get out, extract the informations, then store this information. From a perspective, how long does it take for you to do that cycle, and how maybe you can share some details how you store that it is still searchable and indexed and so on?
Mm-hmm. There are really two completely different things. One is the IPFix telemetry that is obviously extracted from the network traffic on the fly, including this layer 7 metadata, and that's used for the detection in real time. The second thing, completely different, is full packet traces. So whenever you want to capture full packet data, you can do it manually. You can say, I want to capture this specific traffic, or you can let the system capture based on the detected anomalies. So whenever the system will detect a critical anomaly, it will automatically start the packet capture. But there is also a specific trick that we call in-memory buffer. So there is a buffer related to the flow monitoring that stores first 10, 20, depending on configuration, packets with the flow records in the memory of the probe for each flow for like 5 minutes, 10 minutes, depends on how you configure that. And this is available in the moment of the capture. So you can actually go back in time and you can extract those packets that are in this rolling memory buffer.
Just to understand this, so you have these two different methods, but in long term you extract the same information and make them, let's say, searchable for the same item. So I can search across flow data and also the packet captures, or this will be still two different entities that I need to search for?
Yeah, you are right. It's two different entities because the scope of the packet capture is really the full packet capture. So the scope of information that you get is much higher, is the full packet data. What you store and search by default all the time for all the traffic is the network telemetry data, and you can query this data in the so-called monitoring center. So basically what I can do, I can select a specific time frame and I can ask the system, give me, so I can drill down to specific communication and I can see this is my attacker, this is my victim, and this is his attempt to get the access, and I can drill down by let's do really the level of individual flows of individual sessions. And the scope of parameters that you can use to query the data, it's full set of the IPFix information that we have. So when we spoke about layer 7 metadata, so from DHCP, you can get all this information extracted from HTTP. This is the set of metadata that you have extracted. So this is the way how you can query the data that you store for these months using all the attributes from the IPFix.
Pavel, I got 2 questions for you. First of all, I think what you said is that you have this rolling buffer of packets so that when you trigger a detection, because you always need to see the packets first, then you trigger a detection, which means they're already past you in a point of time. And because they're in the buffer, that you can then carve them out of the buffer and write them to the disk because they need to keep it for later inspection. Okay, good. The other thing I wanted to ask is, can you export those packets to a PCAP file, for example, to verify in other tools that the detection is correct? Or to be honest, on the screen that you just showed with your analysis, it still gave quite a bit of a puzzling picture of what should I be doing actually, because it said maybe you want to restart the SMB server, but as far as I understood this was just somebody trying to use login attempts, and it didn't say any of that. So that was a bit confusing. I might want to check it on my own.
Yeah, I agree. I completely agree with you. You can always download the full packet traces. It's available as a PCAP format, so you can download it and you can check it whenever you want. And you are right about the interpretation. So the interpretation goes like this. You have the detection in the anomaly detection system that is telling you, okay, so this activity that I have recognized in the network corresponds to some dictionary attack, and it's classified with this tactic and technique according to the attack framework. And for the PCAP, it's a generic analysis of the full packet trace. And as we understand the layer 7 protocol in detail, we know that Samba protocol version 2 can go wrong on this different status codes, different messages that server will return back to the client. And we try to give some insight what may be wrong. So this is not exactly related to the detection, because the reasons why the session was not established properly, there is a plenty of different reasons for that, and it's difficult to say here, or we don't want to stress the user here by saying always like it might be a compromise, it might be an attack. So we use it carefully only when we are really sure that it's the case.
Okay, so what I get from this is, if you're looking at this picture, it tells us per flow what you think about the flow. And the other one was the aggregated fact that you've seen so many of them that they seem to be a dictionary attack.
Yes.
Okay,
yes.
Thank you.
That would be the conclusion. Hi, this is Pavel Minarik, CTO at Kemp Technologies, and you are watching Security Field Day. In this demo session, I'm going to show the case of ransomware attack and how we detect all those stages of the ransomware attack before it really does the final impact, before it really encrypts the customer data. So these attacks, they really go through certain stages. It's not going to suddenly happen that now your data is encrypted. It has some development. There needs to be initial compromise. There needs to be some lateral movement, usually some data hoarding, exfiltration, and then we have the final step to encrypt the data. So this case is inspired by a real customer case, again, that we have seen in the real environment. And what we did, we built a lab environment where we actually simulated all those steps in the lab environment against the real infrastructure. We recorded all the network activity, and now we have, I would say, pretty comprehensive packet capture made available for education purposes that actually tracks all that activity. So we do have in our setup, we have a compromised device, which can be malware infected or under the control of the attacker. We have a Samba server that keeps and stores company data. We have a remote desktop server that will be our victim for the lateral movement, as you are going to see. And we are monitoring this environment by the Flowmon appliance. So the attacker objective is first to exfiltrate the sensitive data and then encrypt the data and ask for ransom. That's the standard scheme. So how this actually can run step by step in the environment. Whenever there is a bad actor in the environment, or when he enters the environment, he needs to do some kind of understanding what is around. So he runs some discovery to understand what other IP addresses, server services are there, so he can establish his presence and spread his activities. So that's the typical first step. Second thing that the attacker can do is some access to potentially important servers that will hold some data. So attacker can take a list of known logins and passwords, and he can run a password spraying attack against that Samba server. He might not be successful, hopefully, so he needs something more advanced. In our case, what we used and what was used in the customer case was the BlueKeep vulnerability on remote desktop protocol. So that's something you can recognize with the proper signatures for intrusion detection. On the Windows server, what was installed was a keylogger, and that keylogger actually revealed some interesting information, such as user credentials for the Samba server, where the data is stored. So now we have the valid login credentials to access the data on the Samba server. We can download them, and we can think of a method how to get this data outside of the network. So in our case, what we did, we took that data and we split the data into small chunks, and we just ping the data out of the network. It works like a charm. And this is basically getting to the final step, which means the encryption of the data on the Samba server. So responding to the threat at this stage, it's obviously too late, because the attacker is now ready to send you an email asking for ransom for giving you the decryption key for the data, or asking you for the same ransom for not putting your sensitive data on the public internet because it was exfiltrated. So usually there is an attachment to this email with a couple of documents showing that the attacker really has this data available. So I'm actually running that scenario in my lab live in the background. So now when I switch to the anomaly detection system, I will be actually able to demonstrate all these activities one by one. So we started with the network discovery. This is our attacker IP address, and we see two activities. First is ARP scan that looks for devices that are available on the same network, followed by a vertical TCP SYN scan, where the attacker is looking for services that he can compromise. So again, we can see the event details, and we have the classification to corresponding tactic and techniques that are relevant in this case. Another interesting activity that was in the scenario was attack on the Windows remote desktop. So we have again the same attacker, and we have an event saying attack against Windows remote desktop. And when we go to details, we are interested in related intrusion detections. And as you can see, there was a detection triggered that says exploitation of the BlueKeep vulnerability. So after that, the attacker was able to perform the data hoarding. So he was able to download large amount of data from the Samba server. And this was followed by the data exfiltration from the network, where several different methods actually were triggered. The general data upload anomaly that will notify you about a data leaving your organization towards some public IP addresses. But what will be more interesting is this anomaly of the ICMP traffic, because as I've mentioned, attacker split the data into small chunks and ping it out of the network. And obviously, anomaly detection system doesn't like ICMP traffic with a payload. So when we go for details, we can see the event evidence. So these are ICMP packets aggregated into the flows that have been actually detected and flagged as an anomaly. And you can see it's not really a massive amount of data. It's not a lot of packets. It's not a lot of flow. So this is not a volumetric anomaly. And we have a full packet capture available. So in this case, I'm going to download that full packet trace, and I'm going to open that full packet trace using Wireshark, and I'm going to open a file called history, which is exactly the data from the buffer. So we see the ICMP traffic, we see the ping, including the content, which starts here with the file name, followed by the content that was sent out from this network. And I have first like 40 packets available for my forensic analysis in this scenario. So that was really going end to end from the detection to the analysis of full packet trace in Wireshark, and showing all the different details that you can get from the system. And there are different ways how to look at those events. You can look at those events on a timeline, so you can see how these individual attacker activities actually followed one by after another, or how they were detected one by after another. In reality, this is not going to happen in 10, 20 minutes, but in the lab environment, I replayed all the traffic to the network one after another.
So this is pretty impressive, and I wish a lot of my customers, because I investigate ransomware cases all the time now, would have this kind of thing, because then I could go back in time and find out what really happened. Because usually the big question also always is, did the attackers exfiltrate data? And nobody can tell. Sometimes they can show me like a firewall log where you see there's a connection, but nobody knows how much data has been transmitted and everything. So how many data points do you need for this? So how many probes do you need to deploy in the network to get a good understanding of what has really happened in the network? Because if you don't see something passing by, you cannot aggregate this into your logic. So how much collectors do you typically need for this?
Understand. You will be actually surprised. It can go down to 1. Depends on the network topology and the network architecture, because all these things are actually happening between the clients, between the servers, between the clients and the perimeter. So the typical deployment is on the core switch, is in the data center switch. You don't really care about the traffic on the access layer. You don't really care about PC1 speaking to PC2 on the access switch. So all these anomalies will be actually, or most of these anomalies will be actually visible on the core level. So as an example, I can give a hospital that is our customer with like 2,000 beds, probably like 2,000, 3,000 employees. And we have detected in their environment ransomware in action that was starting to encrypt the X-ray images, and they were able to get rid of this immediately because they've seen which device in the network is infected. So they lost something like 5 X-ray images, and the problem solved. And their setup is a single probe monitoring the traffic on the core switch.
Okay, I wish I had this one in my last hospital case, because they encrypted, I think, 13 million files. And yeah, that is a big problem.
And as I mentioned, it doesn't start with the encryption. It starts with many indicators of compromise that can be detected in the network traffic, and the encryption is really the last step.
Yeah, it is. It is basically, it is the one thing where the attacker announces itself or himself to the company and saying, hey, I got you now. Everything else before has been done in secrecy. So if you can detect that, the ransom or the encryption is just the last step.
Yeah, and just an additional question to that. So that is typically the case from, let's say, targeted ransomware, where we have an adversary that is digging into the network. So besides the alarming, you mentioned you have ties into CMs, or how is normally the alarming going from your solution?
Yeah, typically depends on the customer size. Smaller customers, they usually don't have SIEM systems, so they usually go with really notifications from the Flowmon system to their like IT help desk or security help desk. And for bigger customers who have SIEM, they usually use the workflow through SIEM because they consolidate other technologies this way as well. So there is a continuous feed of the events from anomaly detection system via syslog to the SIEM, where the events are correlated with firewall logs, logs from servers, and then the more like high-level incidents are being processed by the customer staff. So it really depends on the customer size, type, maturity.
Sure, makes sense. I can imagine that some customers that are maybe smaller directly looking into the console, and others that have many other sensors will just consume via syslog the alarms and then look into your console whenever there is something already flagged. Yeah.
Exactly. That's the typical workflow.
And I think also like a pre-selection in CM world, a lot is based on how much events you send, but kind of with your solution, you pre-filter all that noise and just send over the alarms that really matter.
Yeah, exactly. The SIEM, they count events per second from anomaly detection system from Flowmon. You will get like, okay, if 1 event per second, that's too much. So it's very, very aggregated and directly to the point. You don't need to process raw flow data in the SIEM. You just need to focus on the results of the behavior anomaly detection from Flowmon that goes to SIEM.
Yeah, like Jasper was mentioned, a lot of the healthcare customers and so on don't have visibility into the network flows because they couldn't afford it. Yeah, so that was one of the main problems. And it's either how many flows per second or it is gigabytes per day, and both are super expensive. So it makes sense. Your model, just I'm curious, how do you count? Do you just count per device, or is there also a volume in the license somehow integrated?
When we speak about Flowmon Collector, so the system that is capturing, storing, and processing the data, I think we have the most fair model on the planet. It's just what disk capacity you need for your historical data retention. That's the decision point for the proper collector, for the proper license or proper appliance. So we don't care about number of endpoints. We don't care about number of flow sources, because with some products, you get really penalized for having 20 routers. And as you are a small organization with 20 branch offices and 20 routers, you can get it pretty expensive. And we don't care. It doesn't matter how many flow sources you have. It doesn't matter how many endpoints. It's just about how your network is big, how many flows per second you are processing. And if you want to have 1 month history or 5 month history, that makes the difference. So it's very fair.
Okay.
I have an additional question about if you're having more than one collector, or no, more than one probe sending the same data, because it has the packets have traveled across the network and you're picking them up at multiple points. So you are deduplicating the incoming events, or are you generating multiple results for the same thing?
That's completely configurable. First thing is, all these duplicates should be under your control. So you should know whether you are introducing duplicates or not in your setup. For the purpose of just the data collection and storage, we don't deduplicate. We store all the flows. They are always matched to the specific flow source, because you want to confirm that the traffic passed through these multiple points. And then when the data goes to the anomaly detection system, there is the deduplication feature. So you can say deduplicate, because all these data are from like one logical segment from the internal network, for example. So the anomaly detection system will deduplicate flows that are measured by multiple different probes or multiple different routers prior the anomaly detection is performed. So you will not get duplicate events.
Okay, thank you.
To that, sorry for asking so much, but this, please clarify. Can you search about across multiple appliances? So I'm making an example. I have 3 locations. In each location, I have one of your appliances. Can I do a search query across all of them, or I have to do 3 searches for each location, an individual search?
No, all is consolidated. So you can do just one search, and it depends what type of appliances. You can have probes and consolidate on a single collector. So these probes will send IPFix to a single collector, and then you just have one appliance that you work with the user interface. If you have really a big environment, you may need multiple collectors. So in that case, we have a concept called distributed architecture, where you have multiple individual collectors, and there is a master unit on top of them that consolidates all the data. And it's, again, a single query point for all the data. So you always have a single console that you can use to query the data.
Wonderful.
Hey, I have a question about the attacks. You mentioned the MITRE and the fact you use their techniques and their sub-techniques. Do you support all of the ones that are in their framework? Do you support any additional ones? And then as a follow-on question, how quickly can you go from an attack technique being defined by the industry then to support it in the product?
Mm-hmm. Okay, so one of the issues of the attack framework is that it's actually defined for all the different technology types. So it covers endpoint detection, it covers network detection response. So we obviously don't cover techniques that are related to analyzing logs from the server or analyzing processes on the endpoint. So it's only related to what you can observe from the network traffic, from the network packets. And from that, I would say if you combine the behavior analysis with the intrusion detection signatures, with the suricata on the probes, you are actually covering that network detection space of the MITRE attack framework. And how fast we are able to, yeah, there was also a question if we detect something else. Yes, we do, because originally we didn't really design it for the attack framework. We designed it based on our experience. So we have a couple of additional detection methods that cannot be really classified directly to the attack framework. Let me give you an example. There is a method that's profiling individual hosts in the network with how many and other different peers they are talking. So this is not really any specific technique in the attack framework, but it's an anomaly that you can trigger that this host suddenly contacted 1,000 IPs in the network. And last question was about how fast we are at the new technique. When we did the mapping, it was actually interesting how one detection method actually covers many detection, many attacker techniques. So it's not always mapping one-to-one, it's sometimes mapping one-to-many. So I would say that when there is something new, we are respond with the software update, which is typically once per 3 months. But it's not really saying that we are not able to detect this specific activity, because on the network, you know how it goes. If the malware needs to contact multiple machines to check if that specific network service is running, you will detect it out of the box, and it doesn't matter if you have a specific signature for that specific malware, because you just do it based on the behavior of that malware. So there would be high chance that existing methods will detect it. It just not may be mapped properly to that specific attack technique. So we need to catch with that in the next version. What also makes life more difficult is the changes in the attack framework. There was version 7, now introduced version 8. So we have version 7 supported. Now we just provided update that is compatible with version 8. It may look like small changes, but actually the changes between 7 and 8 were pretty significant.
Do you have any examples of, you guys mentioned both Hafnium and the SolarWinds incident. Do you guys have any examples of how the anomaly detection system viewed those particular attacks?
Yeah, for the Hafnium attack, we haven't seen the attack based on the behavior detection, because it was really single connection coming from an external site on HTTPS. Like there's really no way how you can do it. So what we have seen, once the attack was known and indicators of compromise exist, we immediately put them into our threat intelligence feeds. So we reported on communication of those malicious actors with the Exchange servers. So that was the Hafnium part. And for SolarWinds, I think it was mentioned here really as an example. I'm not able to say that I know a customer that was really affected by this SolarWinds attack, and it's a Flowmon customer. I'm aware of it, so I don't really know. It may happen, but I haven't consulted that case. The Hafnium thing was much more visible.
So in those examples, if say you've updated your threat intelligence with those signatures or there's techniques, we can then retroactively go back, assuming we have enough storage to see if we were potentially impacted. I know with SolarWinds as an example, it was just DNS requests or requests out to Amazon instances, right? So you could go back and see those destinations and those impacts.
Yes.
Excellent. Thank you.
That's what you can do. Obviously, it will take some time because you will run a query against a lot of data, but you can run it in the background. It's not a problem to start it and pick up the result tomorrow, and you will go through 3 months of all the data, which may be terabytes.
Your threat intelligence information, how often do you update that? I'm assuming that they're rolling updates?
Yes, it's actually updated every hour on our end, and Flowmon appliance is running on customer premise. They call home every 6 hours by default to ask for the updates, so they receive these threat intelligence data. Maybe what I didn't mention, we have also a specific, as I call it, behavior patterns. So we developed our own technique how we can describe something like a signature on the flow level. So it's not really a signature, it's more like behavior description. And this is also opened for the customers, so they can create their own specific detection methods, as well as we are using this mechanism how to push in a new detection method that is able to detect a specific behavior in the network. So that's another thing that it's updated on the fly from the call home. It's not really a call home. It's not sending anything home. It's just getting the signatures or threat intelligence data from our update side.
Yeah, one quick one again, just in terms of the anomaly detection system. Would it the example you gave was sort of an attack on a single host or SMB in that example. What do you see, or is there a way to detect sort of lateral movement within a network? Is that one of the signatures that you would see in the anomaly detection system? And would you be able to sort of follow that in a timeline view or something like that?
Yeah, the lateral movement is one of the categories that is obviously detected as the attacker is like pivoting from one internal system to another system. So that's in the scope of detection as well. From the timeline, well, you will see it on the list of events as they go one by one, but it's not really like a timeline visualization that you can play to see like it popped to this host, popped to this host. It's not there, but there is, maybe I'm able to quickly show it as well. There is the option to do like visual analysis of the activity. So what I can do, I can say visualize event, and this is going to bring me, a specific visualization where I can actually check on what is the other activity of that specific device in the network, and I can drill down to the flow level, so I can explore the activity and other involved IPs by going really from the attacker and checking which other devices actually communicated with that specific device in the network. So this is an option in the system how you can analyze the specific activity
Jason Dover, Vice President of Product Strategy at Kemp Technologies. We've had a great time here participating at Security Field Day, as we always do. We always enjoy ourselves and really can't wait for the next one. Hopefully the next one will actually be in person, get to interact in person in the near future. What we really hope that we've left you with is just some additional thoughts when it comes to how you think about securing your infrastructure and that of your customers. Adopting or including a flow-based network detection and response approach can be really useful. And the point is that it's a tool, right? You have to combine this with the rest of the framework, the right approaches and the likes. But if you do, you can get a lot of benefits, a lot of scale to help you when it comes to mitigating threat actors, doing forensics, even with some of the examples that we discussed in the healthcare and in ransomware. There's some very practical ways that people are leveraging our technology, and we invite you to check it out as well. On that front, if you visit the URL you've got there on screen, you can sign up to get set up for a deployment and an assessment of your own ecosystem or that of your customers. Our sales engineering team will work with you to help get it implemented and come up with a plan on how you will test the technology out inside of your own ecosystem. Thanks a lot for the time today. I look forward to engaging with everyone in the near future.